Hey guys, welcome to your lesson on elements, compounds, and mixtures. Okay, so to start this lesson off, we need to talk about matter. Matter is anything that takes up space and has mass. And there are three different groups of matter. There's elements, compounds, and mixtures, and that's what we'll be going over today. All right, an element is the basic building block of matter. You can't break matter down any farther than into an element. So it is its most pure substance. Now, elements are made up of protons, neutrons, and electrons, but as far as breaking it down into anything that's more pure, an element is the purest that it gets. And if you can find it on the periodic table, then it's an element. So that means all elements are pure substances. Okay, so I like to use symbols for this lesson, so it helps give you a nice visual. So elements, these are all the same element. It's the same throughout. Okay, here's another visual. And I'm going to pull this one up several times throughout this lesson. For right now, I only want you to look at A, atoms of an element. Okay, we're going to look at B, C, and D in a little bit. Compounds are when you have two or more elements that have chemically combined to form a different substance. And you can't separate the particles of a compound. So you have table salt. We have sodium and chlorine, which makes sodium chloride. That is salt. You can't take it apart back into sodium and chlorine. You can't separate the two once it's chemically combined. Okay, so here's an example of a compound. We have stars and circles on the left, and then they chemically combine to form these suns. That process cannot be undone. You cannot undo the suns on the right back into circles and stars. Okay, so we are going to look at C right now, looking at molecules of a compound. So you can see that there's two different colors there. That is two different elements chemically combined. They are stuck together. You cannot unstick them. All right, so molecules are when two gases combine chemically. And you can have either two of the same or two different gases. So water is H2O is one molecule. Or if you look at number B, or letter B rather, on the top right, you see that there's two of the same chemically combined. Oxygen exists in pairs. It's called a diatomic molecule. The prefix Di meaning two. So let's say that that's oxygen in the top right. Two always exist together. Now if you look in the bottom right, the top right is just oxygen. The bottom right, you see there's oxygen molecules mixed with the purple dots, which is an atom, mixed with the compounds, the molecules of a compound. Now that is a mixture. And if you notice, the mixture itself is not chemically combined. Certain things within the mixture are, though. Okay, pure substance. Pure substance, the properties are constant throughout the whole sample. Elements and compounds are pure substances, okay? So anything on the periodic table is a pure substance, and then compounds are also pure substances because it's the same throughout. But mixtures are not, because mixtures aren't the same throughout. They're different throughout. So orange juice is a mixture of lots of different things. You can take out the pulp if you want to, whereas water is a pure substance. It's the same throughout. All right, mixtures. So two or more elements that are physically combined, not chemically. That's the difference between a mixture and a compound. Mixtures, you can take them apart. So I like to use salad as an example. If you don't like tomatoes, you can take the tomatoes out of the salad. They're not chemically in the salad. A cheeseburger, you can take the pickles off of it if you don't like pickles. Dirt and sand, if you wanted, you could easily take out, you could sift out the sand from the dirt. And in the picture below, you could easily take out the hearts if you didn't want the hearts in there. Those are all mixtures. Okay, so here we have a mixture in the middle of A and C. So B represents a mixture of A and C. Again, letter D is a mixture of two elements and a compound. So we have purple, the atoms of an element, We have yellow, which is the molecules of an element, and then we have the compound. So there's a couple different types of mixtures. There's homogeneous and heterogeneous. Remember, homogeneous means same and hetero means different. So water is the homogeneous. It's the same throughout, where milk is heterogeneous. Even though it looks the same throughout, it's not. It doesn't have the same amount of fat perfectly evenly throughout that glass of milk. It doesn't have the same amount of sugar. It doesn't have the same amount of whatever, all the ingredients it's made of looks the same. So homogeneous have the same appearance and composition, and each region of the sample is identical to all other regions of the sample. So salt water, sugar water, air. So in our classroom, the air is all the same throughout, no matter where we would sample it. Here's an awesome diagram, all right? Matter. Matter's broken up into pure substances and mixtures, okay? We just went over pure substances and how they can be elements or they can be compounds. And we just went over mixtures, how they can be homogeneous or heterogeneous. So I want to ask you a question. Are mixtures pure substances? No, they are not underneath pure substances. They are next to them. Can pure substances be mixtures? No, because mixtures are made of different things. Okay, pure substances, same throughout. Mixtures, not the same throughout. All right, heterogeneous consists of visibly different substances. So chocolate chip cookies, oil and vinegar, pizza, gorp. Let's use gorp. Gorp is a heterogeneous mixture with lots of different things in it. Okay, again, matter is made up of two different things. Matter can either be pure substances or matter can be mixtures. And then pure substances are either elements or compounds, and mixtures are either homogeneous or heterogeneous. Okay, same kind of graphic organizer. Breaking matter down for you. And then the last thing is on solutions. So a solution is a mixture of two or more substances. At least two substances must be mixed in order to have a solution. The substance in the smallest amount, or the one that dissolves, or the one that gets mixed, is the solute, and the substance in the larger amount is the solvent. So if we think about camp, we give you guys those little drink packets. The drink packet is the smaller amount. You have less drink packet compared to water. So the drink packet is the solute. It's the thing that's dissolving, and the solvent is the water. It's the thing that the solute dissolves in. So again, your drink packets that we give you at camp that you pour into your water, usually to make your water taste good, because camp water does not usually taste the best, especially at the beach. So we have drink mix is a solute. You dissolve it into the solvent, or the universal solvent, because just about everything will dissolve in water. Anything that will not dissolve is called insoluble. It means it won't dissolve. Oil is insoluble because it won't dissolve. If you try to mix oil and water, it just hangs out. It won't dissolve in water. Okay, so we have concentrated versus diluted. A concentrated solution has a large amount of solute dissolved, and a diluted solution has a small amount dissolved. So if you took like 10 drink packets and you put them in your one water bottle, that would be a concentrated solution. If you took like just a little bit of a drink packet and you poured it in your water bottle, that would be diluted. So concentrated would be lots of drink mix, and dilute would be not a lot of drink mix. Okay, just a couple more things about mixtures. So alloys. Alloys are homogeneous mixtures of two or more metals. So alloys are always metals. And metal mixtures can have greater strength. So the reason that scientists might want to mix metals together is to make them stronger, to make them harder so that they don't break, or more malleable than when they're by themselves. Examples of alloys, brass. Brass is a metal that's actually made of copper and zinc. Stainless steel is an alloy that's made of chromium, nickel, and iron. And sterling silver is actually made up of copper and silver. So all of these common things that you think are just metals that exist by themselves are not. They're actually mixtures of metals. And a metal mixture is just called an alloy. All right, last one, a colloid. A colloid is a heterogeneous solution with medium-sized particles. Colloids can be seen in a beam of light. So if you have ever seen sunlight come into a window and you see dust kind of floating in the beams of sunlight, that's a colloid. Fog, smoke mist. Actually, milk is a colloid too. But the easiest one to understand is most likely the dust, because you. All right, here's again examples of colloids. And again, don't forget to write down any questions you have about any of these things, so that you're sure to get these in a mini lesson back in